Let's talk about sex. Don't worry, I'm not about to have an awkward talk about the birds and the bees, but we do need to talk about how the major factor distinguishing half the global population from the other half is hugely understudied. But first, let's get our definition straight. Biological sex, as in males and females, refers to the sex chromosome pairing an individual carries. Males have an X chromosome with a Y chromosome, whilst females have two X chromosomes. Gender, as in boys and girls, refers to the social characteristics that we ascribe to an individual depending on their sex. My PhD investigates the biological sex differences between males and females in disease. Sex differences are incredibly prevalent across almost all organ systems and diseases. When I investigated for the effect of cigarette smoking, I observed a very interesting pattern. When mothers smoke during pregnancy, we see a higher risk for a range of diseases in male offspring. However, when looking at adult cigarette smoking, we see a reversal of this trend towards a higher risk in females. This sexual dimorphism is particularly prevalent in asthma, a chronic inflammatory disease of the lungs that affects almost 11% of the Australian population. Male children demonstrate a higher number of cases of asthma. However, post-puberty, we see this reversal again towards an increased number of cases in females. As such, I realized that there is a complex balance between sex and disease. My PhD aims to uncover the causes for these sex differences in asthma susceptibility and severity. The Y chromosome is commonly disregarded and just considered a genetic wasteland, with much of the focus on the X chromosome. As you can see, the Y chromosome is significantly smaller and contains fewer genes. However, I believe that this is where the imbalance lies between males and females. Females can't produce genes on the Y chromosome because they don't have one. And a growing body of work shows that these genes contribute to critical biological processes. As such, I've used the revolutionary tool CRISPR-Cas9 to modify these genes and investigate how they contribute to critical disease processes in asthma. My PhD used the first thorough characterization of the Y chromosome in the context of this disease. My results have already shown that these genes contribute to important cellular functions. My findings show that there is a dramatic change in the inflammatory response, as well as a dysregulation of factors that can alter the structure of the airways. These are hallmark features of asthma and contribute to worsened disease outcomes for patients. As such, I highlight that the Y chromosome needs to be considered when investigating disease mechanisms and processes. By increasing our understanding of these mechanisms, we are able to develop more vital and potent medical interventions. So in your own work, don't forget about biological sex differences, and most importantly, don't forget about both sex chromosomes.